We pretty much live our lives online now, and for the most part, it just works. But behind that seamless experience, it's this constant, super high stakes juggling act. So today, we're going to pull back the curtain and look at the invisible jugglers of the internet and the brilliant, kind of simple tricks they use to keep the whole thing from crashing down.
I mean, really think about it. You're streaming a movie, and at the exact same time, millions of other people are in online games or uploading photos, and the whole system just stays up. It seriously feels like magic, right? But it's not. It's actually this fascinating story of engineers solving one problem, which, of course, creates a brand new one, leading to an even smarter solution down the line.
Okay, so to really get the magic, we have to rewind a bit. We've got to go back to the old way of doing things, back to a time when the internet was basically built on these big physical boxes with a bunch of blinking lights.
So, way back in the early days, if you wanted to run, say, a website, you needed a physical server. One big machine totally dedicated to just that one task. The problem? Well, most of the time, that super powerful, super expensive machine was just sitting there, barely doing anything. It's like buying a whole city bus just to drive one person to work every single day. Just wildly inefficient.
Yeah, that obviously couldn't last. The industry needed a major breakthrough, some way to actually use all that wasted power. And that breakthrough? It was the virtual machine. So what exactly is a virtual machine, or VM as we call it? Think of it like this. It's a whole computer, with its own operating system, its own apps, that exists only as software inside another, much bigger physical computer. It's this absolutely brilliant way to slice up one powerful server into dozens of smaller, totally independent ones.
Here's a great way to picture it. Imagine a giant, empty warehouse. That's your physical server. Now, virtualization is like coming in and building a bunch of separate, soundproof rooms inside that warehouse. Each room can be used for something completely different, but they're all sharing the same foundation. It's all about getting the absolute maximum efficiency and wasting almost nothing.
But you know how it goes in tech, right? You solve one problem, and you immediately create a new one. By packing all these virtual rooms into one warehouse, you can end up with some pretty serious congestion. Digital traffic jams, basically.
All of a sudden, if one of those virtual machines gets a massive spike in traffic, let's say a video goes viral, it doesn't just slow down itself. Oh no, it can slow down its neighbors too. The digital hallways get clogged, performance just tanks for everyone, and the risk of the whole system crashing goes way, way up. The warehouse just got way too crowded. So the engineers needed another trick up their sleeve. How do you deal with an overcrowded VM without just shutting it down and messing up the service for everyone? The answer is something that honestly feels like straight-up magic. It's called live migration.
And let me say that key phrase again, no interruption to the service. This is the absolute core of how the modern internet stays online. It's the ability to literally pick up an entire running computer with all its active users, all its processes, and move it to a different physical server somewhere else in the data center, and nobody notices. Not a single person.
Okay, so conceptually, here's how it works. While you're busy watching your movie, the system, in the background, is making a perfect copy of your virtual machine on a server that's way less busy. It copies everything, all the memory, all the active connections. Then, in like the blink of an eye, it copies the last few milliseconds of changes and just flips a switch. Your connection gets redirected to the new location, and you never, ever miss a frame.
But here's the catch. For the longest time, this incredible trick has been mostly reactive. An alarm goes off, a server gets hot, and then a VM gets moved. So the next big question became, what if we could see the problem coming? What if we could make this whole process proactive and a lot smarter?
And this is the crucial difference, right? It's the shift from being a firefighter to being a fire inspector. Reactive migration waits for a server to get overloaded and then scrambles to fix it. Proactive migration, on the other hand, is all about analyzing trends, predicting future traffic jams, and quietly moving VMs around to stop the problem from ever even happening. It's a total game changer.
And that, of course, leads us to the billion-dollar question. It seems so obvious, doesn't it? We have machine learning, this incredible tool that's literally built for prediction. So surely the brightest minds in tech are already using it to intelligently balance these massive data centers, right? Well, a group of researchers decided to actually find out for sure. They launched a full-on investigation to see just how much work was being done on this idea that seems, like a no-brainer. And what they found was genuinely surprising. So, in a recent paper from 2025, a team led by Tawfiq Hidayat did something called a systematic literature review.
What that means is they weren't running their own experiment. Instead, they were basically mapping out the entire field of existing research to see what everyone else had already done on the topic.
And their method was pretty straightforward. They defined their key search terms, things like live migration and machine learning, and then they just scanned the world's top research databases like IEEE and ScienceDirect over a 5-year period. Then they just counted and analyzed everything they found.
And what they found was kind of stunning. In that 5-year span, they found over 6,600 papers on virtual machine migration in general. But when they looked for papers that combine that idea with machine learning, only 172. I mean, that is a tiny, tiny fraction. The big, obvious idea? It was being almost completely ignored by the research community.
The researchers themselves put it pretty bluntly in their conclusion. They said, "We discovered that there are not many papers on this topic in the 3 trusted libraries. Despite the huge potential, this specific area of study was just surprisingly quiet. It was a massive gap in the research landscape."
Now, to be fair, it's not like nobody was working on it. The review did find a handful of studies, some real pioneers, showing that these intelligent approaches really do improve performance and save energy. So the concept was proven to work, which honestly just makes the lack of wider research even more baffling.
So, what does all this mean? Well, it means that one of the most important upgrades to our digital world might just be hiding in plain sight. The future here is quite literally unwritten.
And look, this isn't just some academic thing to puzzle over. Filling this research gap really, really matters. It represents this huge opportunity to build smarter, faster, and way more energy-efficient data centers. And for you and me, that means the services we rely on every single day could become even more seamless, even more reliable, all while using less power. It's a real chance to take our entire global digital infrastructure to the next level.
So it kind of leaves you with this one last thought. We have a really clear problem and a super promising solution that's just been underexplored. It really makes you wonder, doesn't it? What other huge breakthroughs are out there, hiding in plain sight, just waiting for someone to connect the dots?